Hi ladies, this is Mrs. Blaufuss. This is lesson 4.3, and this is talking about transversals and corresponding angles. So if you remember back from Unit 2, we talked a little bit about corresponding angles, and we looked at corresponding angles within parallel lines. So we're just going to zone in on that a little further in this lesson. So if you remember corresponding angles, these are non-adjacent angles that lie on the same side of the transversal. And with corresponding angles, one is interior and one is exterior. So when we say they're non-adjacent, that means they do not share a side and a vertex. And in this case, with corresponding angles, they have different vertices. So in this first example, we're going to identify which pairs of angles are corresponding angles. And so all our corresponding angles, remember, have to have different vertices. They're on the same side of the transversal. One has to be interior and one is exterior. So 1 and 5 are corresponding angles because they have different vertices. They're both on the left side. 1 is exterior and 5 is interior. Another pair would be 2 and 6. 2 is exterior, 6 is interior. They have different vertices and they're on the same side of the transversal. 4 and 8 would be another pair. And then lastly, 3 and 7 would be our last pair. So if you remember back to Unit 2, we looked at corresponding angles within parallel lines, and we said that if the lines were parallel, cut by a transversal, and corresponding angles were congruent, or if we said the lines were parallel and cut by a transversal to form corresponding angles, those corresponding angles are congruent. So in this case, we can see that L and M, they're marked parallel, and it's also in the given statement that they are parallel. So we know that all of these angles, all of these corresponding angles are also congruent. So here we can say, remember, if lines cut by a transversal, if parallel lines are cut by a transversal, corresponding angles are congruent. So let's look at this figure. It says L is parallel to M and A is parallel to B. So you can see by those arrows or those feathers that both of those lines are marked, both of those pairs of lines are marked parallel. So the question is, which angles are congruent to angle 1? Well, let's go through and outline all of the angles that are congruent to angle 1 using a bunch of different methods. So here's what we know so far. Corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary. So which angles are congruent to angle 1? Let's go through and mark. Angle 1 and angle 3 are corresponding angles, so they're congruent. Angle 1 and angle 9 are also corresponding angles, so they're congruent. Angle 1 and angle 7, those are vertical angles, therefore they are congruent. Angle 7 and angle 15 are congruent because they're corresponding angles. And then angle 15 and angle 13, those are also corresponding angles, where A and B are the parallel lines. 15 is an interior angle between A and B, and 13 is an exterior angle between A and B, and they have different vertices. Okay, and then the last one, well, not the last one. Angle 11 is also congruent to 13 because it's a vertical angle. And angle 5 is congruent to all of these yellow angles because a lot of different reasons, but one reason would be 5 is a corresponding angle to angle 13. Okay, so 5 would be an interior angle between L and M, and 13 is the exterior angle, and they have different vertices. Okay, so those are all of our congruent angles to angle 1. All of the other angles, 2 and 8, those would be congruent because they're vertical. 2 and 4 are congruent because they're corresponding angles. So they would be corresponding angles looking at L as the transversal and A and B as the parallel lines. Angle 4 and 6 are congruent because they're vertical angles. Angle 4 and angle 14 are congruent because they're alternate exterior angles. 14 and 12 are vertical angles. 12 and 10 are corresponding angles between where A and B are the parallel lines now, and M is the transversal. So 12 would be an exterior angle, 10 is an interior angle. They're both up on top of the transversal M, and they have different vertices. And then lastly, 10 and 16 are congruent because they're vertical angles. Okay, so now if we know that the measure of angle 1 is 62 degrees, find the measure of angle 10. Okay, so we have to first find angle 7 or some other angle. So if angle 1 is 62 degrees, then angle 7 is also 62 degrees. And if angle 7 is 62 degrees, then angle 10 has to be 118 degrees because we know that the measure of angle 7 plus the measure of angle 10 has to equal 180. Because these two angles are consecutive interior angles. Okay, so if I know that the measure of angle 7 is 62, plus 62 plus something has to equal 180. So if I subtract 62 from 180, I get 118. Okay, so therefore the measure of angle 10 equals 118 degrees. There are several ways you could go about this. This is one way. Another way is you could find the measure of angle 8 because 1 and 8 are a linear pair, and you would get 118 degrees for the measure of angle 8. And 8 and 10 are alternate interior angles, therefore they have to be congruent, which makes measure of angle 10 also 118 degrees. And then a third way, but not the final way, is that you could find the measure of angle 2 because 1 and 2 are a linear pair, and linear pair angles are supplementary. Once you know that measure of angle 2 is 118 degrees, we know that angle 2 and angle 10 are congruent because they're corresponding angles. Therefore, angle 10 has to be 118 degrees. So there's a lot of different ways you can do this example. In this lesson, we have a new theorem. It's called the perpendicular transversal theorem. And this theorem says that if a transversal is perpendicular to one of two parallel lines, it is perpendicular to the other. All right, let's try this next example, example 2 that you'll find on your note sheet. And this says that in the figure below, P and Q are parallel, and R is a transversal that's perpendicular to Q. It tells us that the measure of angle 2 is 3x minus 6. We need to find the value of x. So the first question I have is, what's the relationship between the given angle? Okay, so I know that R and Q are perpendicular, So first of all, I know that perpendicular means that the lines intersect at a 90-degree angle. Okay, so I know that this angle, and it's marked as a right angle, so I know this angle measures 90 degrees. So the first question is, what's the relationship between this angle that's measured 90 degrees and this angle, 3x minus 6? Well, these two angles are alternate exterior angles. And I know that Q and P are parallel, so they are congruent. Alternate exterior angles formed by a transversal that cuts parallel lines are congruent. So I can use just an equation that sets the two expressions equal to each other. So 3x minus 6 equals 90. And then from there I can solve for x. I'm going to add 6 to both sides, and I get 3x equals 96. And then I can divide both sides by 3, and I get x is equal to 32. Okay, and all we're doing is finding the value of x. And when I plug in 32 for x, I should get 90 degrees because I know that those two angles are congruent. And if I do that, 3 times 32 is 96, and 96 minus 6 is 90 degrees. So that's how I would double check. Okay, let's do one more example. And here it says which lines, if any, are parallel. So here we're going to use that converse of our corresponding angles theorem. Or the converse of alternate interior angles theorem. Or the converse of alternate exterior angles. Okay, so this tells us that if corresponding angles are congruent, then the lines have to be parallel. The converse of the alternate interior angles theorem says if alternate interior angles are congruent, then the lines have to be parallel. The converse of the alternate exterior angles theorem says if alternate exterior angles are congruent, then the lines have to be parallel. And the last one we could use is the converse of consecutive interior angles theorem. And this says that if consecutive interior angles are supplementary, then the lines are parallel. Okay, so let's look first and see if we can find any alternate interior angles or any corresponding angles. So here, this 72-degree angle right here, and this 82-degree angle, those would be alternate interior angles between C and E. And since they are not congruent, I know that C is not parallel to D. Okay, let's look at another one. Let's look at the converse of, so this was, let's say, the converse of the alternate interior angles theorem. Let's look at the converse of the consecutive interior angles theorem. This 82-degree angle and this 104-degree angle, those are consecutive interior angles, here and here. So they have to be supplementary if the lines are parallel. And in this case, they're not. They add up to 186 degrees. And to be supplementary, they have to add up to 180 degrees. So I know that D is not parallel to E. Okay, so we know that C and D are not parallel. We know that D and E are not parallel. Let's see if, oh, here, this should be C is not parallel to E. and D is not parallel to E. All right, let's see if C and D are parallel. If C and D are parallel, then corresponding angles will be congruent, alternate interior angles will be congruent, alternate exterior angles are congruent. So we need another angle. So I'm going to look here. Since I know this is 72, I know that this angle is also 72 because they're vertical angles right here. And, oh, I already decided that C and E are not parallel. And then let's find this angle right next to 72. I know that a linear pair of angles has to be supplementary. And so this yellow 72 that's given and this missing angle right next to it would be its linear pair. So I know this is 108 degrees. Okay, this angle right here is 108 degrees. 108 degrees and this 104, those are corresponding angles. Okay, so if C and D are parallel, then the corresponding angles would be congruent. So I can also decide that C is not parallel to D. Now the only thing left to decide is whether or not A and B are parallel. And here I'm going to look at the angle that's given right here, this 108 degree angle. Let's erase all the other ones. So this 108 degree angle and this 108 degree angle, those are alternate interior angles and they're congruent. Therefore, A and B are parallel. And those are my only set of parallel lines. C, D, and E, none of those lines are parallel to each other, but A and B are parallel because alternate interior angles are congruent. That's not the only way you could do it. You could also find this angle right here. It's a corresponding angle to 72. So it has to be 72 if they're parallel. And because of the linear pairs theorem, 108 plus 72 is 180. So the linear pair is supplementary and the corresponding angles are congruent. Therefore, A and B are parallel. So please jot down any notes or questions that you have and we can go over them next time I see you in class. Thank you.